Good day from Chem Help ASAP. In this video, we'll examine some typical enzyme inhibition and receptor activity curves. Upon completion of this video, students will be able to explain IC50 values for enzyme inhibitors, explain EC50 values for receptor agonists, list different types of agonists, and explain IC50 values for receptor antagonists and inverse agonists. To the left, we have a standard curve for an enzyme-catalyzed reaction. On the x-axis is the concentration of the substrate, and the y-axis shows the rate of the reaction, measured at the start of the reaction. The equation below is the Michaelis-Menten equation and correlates the rate, often written as V naught, with the substrate concentration. Going back to the curve, at low substrate concentration, the rate is low. The rate rises quickly with substrate concentration until you hit a plateau. The plateau is the Vmax, maximum reaction rate. How is this curve affected by a drug, such as an enzyme inhibitor? Here we go. The blue line is the same and includes no inhibitor. The next line, the red line, shows the effect of a small amount of inhibitor. The next lines, green and yellow, have more and more inhibitor respectively. As you can see, with more inhibitor, the rate is reduced. Although with enough substrate, the same Vmax will be achievable. This is what enzyme inhibitors do. They slow the reaction. Note that there are multiple types of enzyme inhibitors. These curves are for a reversible, competitive inhibitor. Not all enzyme inhibitor drugs are reversible and competitive, but most are. If you choose data points on this middle graph at a fixed substrate concentration, you can plot them as reaction rate versus logarithm of inhibitor concentration to get a set of points that fit a sigmoidal curve. The inflection point of this sigmoidal curve occurs at something called the log IC50. IC50 is the concentration of the inhibitor required to reduce the reaction rate by 50% of the uninhibited rate. IC50 is a standard way to measure and communicate inhibitor activity. Compounds with a smaller IC50 value show enzyme inhibition at a lower concentration and are considered to be stronger inhibitors. For receptor ligands, let's start with the endogenous ligand, the natural ligand for the receptor. Ligand activity normally involves plotting the effect of the ligand, also called response, against the log of ligand concentration. You generally see a sigmoidal relationship that reveals a maximal effect, Emax. The midpoint of the curve occurs at log EC50, and EC50 is the ligand concentration required to achieve 50% of Emax. Emax caused by the endogenous ligand defines 100% effect for a receptor and full agonism, fully turning on the receptor. Drugs that are receptor ligands and turn on the receptor can show different degrees of agonism. If the Emax plateau from a ligand is greater than 100%, then the ligand is a super agonist. If less than 100%, then the ligand is called a partial agonist. Confusingly, the midpoint, the inflection point of each sigmoid for each ligand is still called an EC50 value. So this line, this gray line, for a partial agonist only reaches about 40% effect. Its EC50 is still measured at just 20% effect, which is half of that particular ligand's maximum effect. Both antagonists and inverse agonists have similar activity curves, which resemble an enzyme inhibitor. These curves start with a high effect, and that requires the experiment to include a high concentration of an agonist to turn on the receptor. As the concentration of the antagonist or inverse agonist increases, the effect of the activated receptor is diminished. Again, we see a sigmoidal relationship, now a downward one. The activity of these ligands is reported as an IC50 value, the concentration required to reduce the response caused by the agonist by 50%. We have now worked through different uses of IC50 and EC50 values to describe the activity of both enzyme inhibitors and the various receptor ligands. I hope you feel more comfortable examining and interpreting enzyme and receptor activity curves. Please leave a like, make a comment, or subscribe to the channel. Take care.